Okay, I'm going to start over again for the people out there in TV land that haven't had it. So today's lesson is to look at a single aspect of file management, which is downloading file from a remote website. When we get this working, it saves you having to do the select, right click, download, save target as, which if you get stressed, you might actually unintentionally click on a link and wonder why it didn't download. And then you'll send an email to me, which I'll immediately trash without reading. So this will save a lot of pain and suffering for everybody. To get the file from the remote server, we have to know where it is. We actually have to know its public address. And then we need to interface with the remote server. And we're going to do that using the Python package called requests. There's a couple of other Python packages that perform similar tasks. Request must have been the first one that came up on a web search when I did it several years ago. So again, I'm not familiar with any of your Anaconda installs. There's 50 of you in here, 20 of which are invisible people. But for the 30 visible people, the odds of all 30 of yours installs being identical is pretty slim. So there's going to be individual variation, and it's not from anything you did wrong. It's just where the moon was at the time you did the download. So you might have to actually install the package itself. So for example, on my computer that I'm demonstrating with, this is how I installed the request package into the Jupyter Hub subsystem with Python. Likely with Anaconda, you're going to use the second one, some kind of like Conda install package name. That would actually be my first attempt. I would suggest you try. Simply go into your Conda PowerShell and Anaconda Navigator, upper left-hand corner, PowerShell thing. The screen pops up and it's waiting for command line input. Looks just like a terminal window, and you type Conda install requests. Hope for the best in that case. But I would first try this. Just go ahead and try importing requests right away to see if it's already there. So obviously on the demonstration, I've already done these two steps. Maybe not obvious to you. I will stipulate, I've already done it. I have requests attached to my kernel. So now to use the request module, I simply just have to import it in a script. So what happens when you attempt to use a module that's not accessible to your kernel? What happens when you type import, whatever that module name is? Okay, you get the pink box, correct? And what's inside the pink box? What does the narrative say? You don't have to be exact, just close. Yeah, it says module not found. It's something like that. When you see that, you have a couple choices. You can throw up your hands and go, I'm going to just go over to the business school and get a real job. Or you can like break down crying because it's the end of the week and nothing's worked the whole week, and that's fine too. And then after that's over with, Conda install requests, hope for the best. And if it's working, or at least if it attempts to find it, you should get there'll be an interface and it has bars going across and it says going out to web directory, and it tries to download the stuff, and you'll know. If it doesn't download it, it gives you a message, in which case your life gets temporarily a little bit more miserable because you actually have to find the package and get it downloaded and installed in your machine. That's the hardest thing of using Anaconda or actually any Jupyter installation, is getting all the bits and pieces that you find on the internet that look really cool. After we've imported the request module, assuming it loads, the next step isn't absolutely necessary, but I'll do it because we're going to demonstrate this shortly. Is you might actually want to remove the file from your local machine if you've already done this. That might be just a one-off thing. But if you're pulling data from a remote server, repeatedly, you want to destroy what's on your local machine first so they don't get buggered up. So that's all this does. This just destroys a copy. So the file we're going to get is called all quads gross evaporation.csv. And we are told that it's located on a server http://54.243.252.9 ENGR-1330 web root /databases all quads gross evaporation.csv. So let's actually go to that site and see what's there. http://54.243.252.9 ENGR-1330 web root. I think it was 4 databases, wasn't it? I guess it was, because my browser up there remembered that I've been there at some point. So here's this directory sitting out on a web server, and anyone in this room could get to where I am right here, unless you're on a Windows machine, in which case it would look different. So there's our a.txt, all quads gross evaporation, and I'm in Firefox on a Macintosh, so it's whatever it thinks the most important thing to do. It attempts to download stuff first. Okay, so it looks like that is a remote web server with all sorts of interesting. So I'm just picking on random files that I know will actually render. If they're big, it just attempts to download them. So that's just a feature of a Macintosh. Other computers find other ways to not do stuff. And here is how we would use requests. So the actual use of the request package is in this line right here. So we're using from the request package, so that's the word requests, the dot function name formula. There's a function called get, and the syntax of the function is the fully qualified domain name to promote, and then whether or not to allow redirects. Generally, it's advised that you set it to true in case that remote server is internally redirecting somewhere else. And that's how you get the remote resource. In this case, we've assigned it to an object name. Arget. What other name could we give that object? Yeah, we give it any. We could call it Fred. It's just a variable that we use internally in our script. And then once our get is getted, we can create another object called local file. We open the file. We're going to give it the name all quads gross evaporation. And then the WB flag is right. And I forget what the B is. It basically creates the file and prepares it for writing. And then to our local file object, we will use the write function. And what are we going to write? We're going to write the contents of our get that we just read from the internet. And we're going to use the content command and then close the local file. And then if we examine what type our local file is, we have input output buffered writer, which is just another weird object. If we gotten some kind of error along the way, the class of the local file wouldn't be that. It would have some sort of goofy looking name. And usually if it fails, we get the pink box. And then finally, we can see if the file actually exists. And then make usually the worst error here is to go ahead and print the file. If you're downloading from a website, the files don't. So you may want to skip this step, but as we're learning for this first one, so here's all quads gross evaporation. It's sort of a big file. Scrolling, 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 scrolling. Looks like we're up to the 1960s. So I was alive by then. Scrolling, scrolling. 1970s. Scrolling. So that's this silliness is on purpose. And then we'll get up to, so 2020. So we're getting around to where you guys are alive. Young perhaps, but alive. Okay, so big file. So just in commenting that particular file, that structure kind of looks like a spreadsheet, which is expected. You'll notice, actually, we don't notice the unusual character because it's rendering correctly. We'll try that in a different venue in a second. But if you do choose to examine the file, even just a little bit of it, you see a funny character, which is caret and then a capital M. That happens to be an unprintable character, which is the carriage return and line feed. So that's a control character from an MS-DOS architecture. So normally what that means is that that file was created on a Windows machine. You're reading it on a Linux or Macintosh machine. A lot of times the APIs are smart enough to interpret it for you, but sometimes they don't. And if they don't, you have a lot of choices right here. So here's just some simple bash shell script commands that will work in Linux type environments. So that's Macintosh, Linux, and modern Windows actually has a Linux subsystem, so you can actually access these. The first two are using something called a string editor, and those are global search and replaces. And so the first one would take Unix to DOS, where we're adding carriage returns. The second one is DOS to Unix, where we're removing carriage returns. Perl scripts, most computers have Perl built in. First one converts a file to a DOS file, converts to a Unix file, converts to the old Macintosh format. The point being not that you would necessarily understand these just by looking at it here, trying to stay awake on a Friday morning on what looks to be a lovely day. So hopefully you can skate out of school early enough today and enjoy some of today. But that the funny characters is not the end of the world. If you're going to the trouble to download this file, you must be doing it for a reason. So in that case, you would search how to convert file types to add and remove carriage returns and hardline feeds. So now in our example, we'll go ahead and continue to read the file for some processing. So let's go ahead and bring to life an actual Jupyter Lab notebook, and we'll get our favorite one, Untitled 1. We'll go ahead and tidy it up. So Untitled 1, for all practical purposes, is an empty notebook. This has to be running on a server back at my house. So it's not running here locally, but that's kind of irrelevant. There's nothing in that notebook that should let us get the file. In fact, let's go even further and create a directory to work in. So let me get a new folder. So somebody come up with a wonderful name, not too long, for our directory for playing in.
Untitled 1 folder.
I'm going to try playground. That's what you meant to say. So there's our playground. And now we will put Untitled 1 into the playground. Get in there. Oh, you want to be that kind of smart aleck. Plan B, we'll just go ahead and launch one. Okay, so we have Untitled in the playground. I'm going to kill Untitled 1. Oh, that hurts so much. Okay, empty notebook. We're in a directory called Playground. Is there anything else in the directory? Currently, no. Our file system is showing that directory is empty, with the exception of one and only one file, which is called Untitled. Would you like to name the file? Let's give it a name. Friday. That's name it after your favorite movie. Okay. So contents of our directory named playground. Friday the 13th.ipynb, and there's actually a hidden file there that we can't see, and that's it. That's all that's in the directory. If we wanted to see what was in that local directory, we could import systems and so that'll tell us we're in home, Sensei, Engineering 1330 Web Root Playground. And let's, we're now going to look at the entire contents of that directory. So it has Friday the 13th, which we knew of. It has a hidden file called .ipynb checkpoints, which is just a restore point file. That's how we get away with killing the kernel. And then we have two other system files, dot and dot. Dot is the inode location to the current directory, and dot is the one that resides inside. So more than you need to know. This is a TMI Friday. Kind of cool. So we'll go back to our example here, and actually we'll run it live. So we need requests. So here goes nothing. It should work, I think, but maybe we'll get the pink screen of yay. Okay, so import. Okay, which means I have already done the sudo -h opt user bin Jupyter Hub install a request. Well, so far so that good. That's wonderful. Let's go ahead and get the file. So when I run this script, it's going to attempt to go to HTTP 54.243.252.9 Engineering 1330 web root for databases, all quads gross evaporation.csv. That's what it's going to attempt to. Now, is that a different server than the one this script is running on right now? Yes, because the one we're working on right now is 75.3.84.227. They are in physically different locations. The server we're requesting from is located in West Virginia, in a hauler, and the server that we're running on is located in Lubbock, Texas. Duct tape behind a television set. So they're physically separate. They're not the same server. And if you're aware of multi-homing machines, you're going to have to trust me because I have no easy way to show you that they are not physically the same machine with just two different network interface cards with two different assigned internet protocol numbers. That's another way to trick it, but I'm not tricking you. Sure you're not. Okay, so I'll go ahead and execute the script in a second. And what I want you to do is kind of keep your attention over here. Don't worry, it's not going to happen fast. And we will see if a file called all quads gross evaporation.csv comes into being. So we get to the right cell, press the button. Kernel is idle. So we didn't create an error. We'll give it a chance to catch up. And then because we're in, there we go. So magically, all of a sudden a file appears. Now we can take a look at it because there's a couple things that can go wrong along the way. So the fact the file appears really only means that local file successfully executed. It created a file to take input. We don't know if input's there, but we can find that out by taking a look at it. Okay, yeah, that was successful. Hooray, successful file download because it got the data. If it fails, it's usually, you usually get about 7 columns, 7 rows, and 2 columns of gibberishly looking stuff. I mean, it's still characters of the alphabet, but that was a failed download. Usually that means that the remote file actually didn't exist. And so when we opened the local file, oh, and the B means clobber what's already there. If the file's already there, destroy it, if not, create it. So if we get the gibberish in just the first few lines, and then the files aren't very big, they're basically 0K in size. Failed to do the actual download. And the reasons for that, you got something wrong with communication. The remote file didn't actually exist. And then you have to go ahead and debug that. But in this case, we're successful. There's what our file looks like. We scroll down and we can scroll across. And it's, as files go, that's not particularly teeny. You wouldn't want to load that into a spreadsheet and try to find something because it would be tedious. All right, so we have grabbed a file from the mighty internet. We could choose to verify it exists. We could choose to look at it in the, let's go ahead and do this just for grins. See if we get the, so I'm going to use the system command concatenate, which is cat, and I'm going to have it attempt to render the contents of the file. And it works. As you can see, it's kind of just showing us the end part of the file. All right, let's continue with our example. Here's what the whole file looks like right there. Now we're going to process the file. So all we have is brought the file to our local machine. It's still not part of our script yet. And so we're now going to open the file. We'll create a list called a list because we have no creativity. We'll keep track of row numbers, and we'll just start reading each line of the file. And when we get to the end, we'll close it. And then we'll print the first 10 rows of the file. So anything there scare you? We've done this in labs already. So by default, you already know all this. So let's go ahead and see what we're about to instruct our machine to do.
What keep track of the row number?
Have it. Yeah, have it. So we have a local file. We're going to open it. All quads, gross evaporation. So local file up there is just an object name. We could name it something else. What name? What other names could we give it? Cork, Kentucky, Brotherhood, Budweiser. Let's see who else is wearing. Colorado Tech, Texas Tech, or Carhartt. Any of those would function just fine as a name. But again, you probably want to give a name that you'll recognize 2 years. Certainly you'll still recognize Kentucky, but you won't know why you named an object Kentucky, but you will know why you named a local file. And then similarly, a list could be any Python acceptable name. And then row number A, like I said, is a habit on my part. And then we will read the contents of the local file one line at a time. We're doing a string split, we're going to split on commas. That file happens to have commas to separate fields, and we'll use the split command to separate the fields, and then we'll append the split line into a list. And think of what that's going to happen. A list is an empty list. We read a line of a file. That's just a string. Then we split the string based on the presence of commas. Now that is a collection of substrings. We put that into a list. What is that first object of the list going to be? Also a list. So we're implicitly building list of lists. And then finally, we will print it back out because I happen to know that the list is going to take on the properties of a list of lists. Here we're just doing a constructor notation to look at the first 10 rows and the first 10 columns. So if you think of that file, the CSV file, wide thing, and it's got hundreds and hundreds of rows. We're looking at the 10 by 10 upper left-hand corner. Well, let's see what happens. There's two possible outcomes, three, I guess. Pink screen of failure. It works, or something I don't know what's going to happen. So now it has shown us the first 10 rows. So here's row 1, 2, 3, all the way down to 10. And it's printing whatever those rows are, the first 10 columns. So let's go ahead and quickly make a change. Let's suppose we didn't have the a priori knowledge that it was going to produce a list of this. Let's suppose, yeah, okay, I just want to look at the first 10 rows. Is that going to work? Well, probably, because I wouldn't waste my time if it wasn't going to work, but I make mistakes. And it says closing parentheses does not match. Oh, my bad. Why didn't you all tell me that? You just like to see me get the pink screen of failure. And yeah, printed 10 rows of something, but it's kind of hard to see what the rows start. There's the first row, second row, third row, and a bunch more down. So we read a file, and we happen to be a file that has a matrix-like structure, and all we want to do is just look at the first 10 rows. So this would be 0 to 9. It would end at 1954-09. We'll go ahead and verify that. And it would go to about, let's see, column 1, 2, 3, 4, 5, 6, 7, 8. And I think it will pick up the column that's labeled 206. It might be one more to the right, 206 or 207. So we will go ahead and so it's 1954-09 as expected, and it goes out to column 2, the column that has labeled 207. So that's how to read data from a remote server. I think that's all I have for today. It's also possible to do it from a server that is encrypted. And I'll leave that for you to read on your own on the internet. The trick there is there's settings that go into the requests command to tell it to ignore certain features of a self-signed certificate. You actually really got to put some work in to ignore the security features. If it's a valid certificating authority, authorizing certificate, it works pretty good just on defaults. That's a fairly advanced technique that someday you're going to have to learn, but we're not going to do it today. Here's another example. If you recall, when we did the matrices, you right-clicked and downloaded a matrix.txt, b.txt, and x.txt. I think those were the three. Here we'll just do the same thing. So we'll read it directly from the remote server. So this time, instead of doing the right click, which was like go to the databases, select the file, right click and download it, which will work. But the whole point of scripting is to take as much work away from you and give it to the machinery so that you have time to sit there and enjoy a beautiful day like today, drinking mint juleps out under a tree or whatever you like to do, whether or not you like to be under trees or not. So because I don't like to remember how to do stuff, I will just copy what I've got there, paste it there, and let's examine what we've copied and pasted. So import request, we didn't necessarily need to do that again. The remote URL, that's been changed to go to the file that we actually want to read. And then we will run the request get, we'll open the file, read it, and close it. So again, keep your eyes over here. So the file is currently not there. Go ahead and execute that, and all of a sudden, miraculously, almost instantly in this case, a.txt appeared. Let's see if there's anything inside a.txt. Lo and behold, there is. That's cool. So I think the rest of the example now gets really simple. So now we'll read the contents of the file. So since this is computational thinking, anybody knows a pattern of what's going on? I haven't provided any new logic after I got the first one. I'm literally using pattern matching and repetition and changing name necessary to do the same thing over and over again. Because again, the end goal is no brains required. So now we will read the matrix. Again, this case, we're going to split on white space. Let's go look at our file. So it'll split on those blanks. So those look like 1, 2. Yeah, it looks like there's 2 white space characters between every data item. Run that. Gee, it didn't look like it did anything, which is it. There was no output. Let's go ahead and just look at the matrix or the data we've just read. And where did I get that script from? Lab 7, example 1. Nothing's been changed. I just cut and pasted. And there's the matrix we just read completely from a remote file. Now we can get fancy and put everything in the same cell, which once you get it working is probably fine. But as you all have personally experienced at some point in the last few weeks, put everything in the same cell and something goes wrong. It's horrible to try to interpret what comes out of the pink screen of encouragement, even though it does its best to try to point out to it. It's not so, it wouldn't be so bad in this case if this broke, but if we have functions, because it's got to trace back through the defined functions, it starts to get to be a real nightmare. So here's everything in a single line. Let's go ahead and be real honest. So we will cut that. Now we'll read a.txt and print it back out to ourselves all in one fell swoop. Oh, actually, let's be honest about this. It's gone. Done. Went out to the server, grabbed the data, processed it. That's about all I wanted to accomplish today. Does that seem a little bit easier than right-clicking and downloading stuff? Maybe not for the first case, but yeah, it's a way better way to do it. Now, if the remote server administrator moves files around to screw with you, then maybe this isn't such a good idea. But normally they don't. Normally you're accessing fairly large files, and there is no logical reason for you to manually download it if you're doing data science kind of stuff and re-accessing them over. This is the way it's supposed to be done. And if you look on blog posts for data science, because perhaps some of you have when you have trouble sleeping, that's probably the first thing that comes to mind, is to go ahead and search the internet on data science blogs rather than get YouTube videos that are relaxing. You'll see that almost all of them store their data in files and only provide URLs to the files. You're expected to know how to download it and get it to run. All right, that's all I have for y'all today. Thank you for your attention and mostly staying awake. Before you run off, since I own you for 4 more minutes, well, I don't really own you. I should have your attention for 4 more minutes. Let me go take a look at the lab. So the lab today is 7.1. Numbering is admittedly not what you expected. So we'll go look at the lab. So literally the first example is the one you had in lab 7. Guess that was what, last Wednesday? But you want to substitute the manual download with the script to do it. And then again, you should get the same contour plot. And then we got the treasure map, and here it's been sanitized quite a bit. Here you want to read treasure 2. And again, do it entirely by remote control, and it should tell you that cell 4.3 contains the treasure. And that's your lab. See, what's the exercise? Oh, you can forget the exercise because the actual example is the exercise. Josh probably hasn't seen this any more recently than you have, so you can feel free to interrupt him when he starts to do the exercise. So now the example is the exercise. We're done. All we got to do is turn the lab in with our name. Exercise set 7.1 doesn't exist yet. It'll exist before you're done with lab. And it'll again be along the same venue. I think I'll take the exercise 7, pull some pieces out, just have you download a file, complete that exercise. It's supposed to be easy. So the goal for day in lab is to get requests working on your machine. All right. See you in a little bit.